For this tutorial, I'm going to be making a fidget spinner using Techsoft Design version 3. And my objective here is to work with the transformation tools which are part of the Techsoft software to create a very precisely engineered finger CAD file for this fidget spinner. Okay, so first of all, what I've got up here in the top right corner is an image off the internet, which is showing me the size of a skate bearing. So this is what I'm going to be using in my fidget spinner. And what I'm going to do now is, well, first of all, let me just think through my thinking here. Let's just start off by creating a circle here, which is going to represent the external diameter of that bearing, which is 22 millimeters. So I'm going to go to the circle tool here, hold the mouse button down. I'm going to go to the second tool, which is to draw a circle of a given radius. I'm asking for the radius here. The diameter is 22, so the radius is going to be half of that, 11 millimeters. I've got a pale blue grid here, as usual, and I'm going to grid lock. It's a 5mm grid, and I'm going to position this in the center of my fidget spinner. Okay, so there it is. That's going to represent the central bearing cut out of a piece of material, for example, plywood. Okay, actually looking at the size of the bearing here, I can see it's got a thickness or depth here of 7 millimeters. So actually, rather than plywood, I'm thinking here that I could make this for me, because plywood normally comes in like 3.5, 4mm thickness. I'm thinking a thicker material. This could be done in 6mm thick MDF, or actually I think acrylic might be better. And we could do it, for example, in 5mm thick acrylic. That could be really cool. Now, my thinking about this fidget spinner is that I want it so that I can grab it between my finger and my thumb and it will spin easily without it colliding with my hand. So what I actually need to get here is some anthropometric data of the sizes of people's hands. So to do this, I'm going to do a search here on the start menu for people size 2000 easy. Now this is the ergonomic data that we have here, and I'm going to run that. So here we are. This is the software running, and we have all sorts of different ergonomic data here for the sizes of people. I'm going to go to the hand settings. I'm actually just going to pull this in a little bit now that I've got the hand. Let's just bring that into that point there. What I'm wanting to work out actually is the distance between, let's have a see, the tip of the thumb and the actual corner of the thumb joint there. I think that's what we're referring to. Let's bring this to the side a little bit here and have a look at this. Okay, so at the moment it's looking at British males and British females. If I go to all the settings, you can see that in here we actually have a wide range of data, but many of these things are grayed out. So we have Italian, French, Dutch, what else do we have in here? Japanese, okay, but we don't have the sizes of children, unfortunately, for the Japanese sizes. We only have the sizes of children for British and American children. So I'm going to go with US girl sizes here for the minimum size. I'm going to go with the bottom 5th percentile. So that effectively means that if you were to have 100 US girls randomly selected, I'm looking at the size of the and then listed, sorry, in order of increasing size of hands from smallest to largest in a long line. Then this would represent the 5th person along in terms of size of hand. There'd be 4 people who would have smaller hands than this, and the other 95 people would have bigger hands. So that's a nice way of finding sort of the minimum range in terms of most people. I'm thinking here that this could be designed for a girl who's aged 8, and I don't really need the maximum size here, but let's go with the 95th percentile here of a US boy, and I'm going to put this at the age of 16. So that's kind of my target market here. 8 to 16-year-old children, and I'm going, particular details I want here is my 5th percentile for my girl. So let's just confirm that. And now what I get is the fact that that distance between the tip of the thumb and the arch here at the base of the thumb is, for the smallest size hand, the 5th percentile 8-year-old American girl, is 43 millimeters. And for the largest 95th percentile US boy age 16 is 77 millimeters. So the 43 is what I'm going to work with. Now it's a little bit not precise here, because what I'm actually looking at here is the distance from the tip of the thumb to the base of the arch here. And actually I'm going to be holding my fidget spinner more in the pad of the thumb here. So if I was being really quite technical about this, what I would probably do is bring this in another 5 millimeters. But as you'll see, that's going to make my fidget spinner very, very small. So, therefore, should I modify the data? So I'm working, for example, with a 12-year-old US girl, bottom 5th percentile here. Should I just measure my hand physically itself in front of me and use that as the measurement so it's comfortable for me to use? But I'm going to go with this data here. So it's a little flawed, but hopefully you get the idea. So what I'm going to do here is just do a screen capture of this. That's Windows key Shift S. Let's just capture the data like that. And now go back to Techsoft Design. I'm just going to paste it into my CAD file here. So I've got my research to reference to. Okay. Right now, let's just think about this. I know that my fidget spinner cannot extend beyond 43 millimeters as it spins. And for me, that is going to be the radius. So I can see the fidget spinner is going to be extending out here. Let's just try and draw some kind of line here that's going to represent the fidget spinner. Let's just turn off the gridlock here just to show this. I'm imagining that my fidget spinner is going to go somewhere in my hand like that. Now, I'm only looking here at the thumb. Okay, but the point is that my thumb is going to be grabbing the fidget spinner in the center. I'm imagining there's sort of like a center spindle here with the bearing. That's slightly too high there, but you get the idea hopefully. And I want it to be able to spin so it passes between my thumb and my first finger. So that's the basic idea. Let's just get rid of that there. I don't really want to keep that. I'm going to come to the circle here with a given center and radius, and I'm going to put this to be 43 millimeters for the radius of this circle, and I'm going to define the line type here to be a dotted line because I want this to be a construction line. I'm going to make sure gridlock's turned on, so I'm stepping to the grid because I want it to snap to the center of where this central bearing goes, and I'm going to click. Okay, so this effectively creates a border around which the rest of my fidget spinner needs to work. I'm thinking now with gridlock turned on, I'm going to bring that a little bit to the side there. And now I'm going to zoom in a bit over here so I can see more clearly what I'm doing. Okay, fantastic. So I'm thinking here that I'm wanting to have another cutout. I'm actually going to use bearings here for the weight in my fidget spinner. So I'm actually going to have 4 bearings, one in the middle, and then I'm going to have 3 bearings as kind of planetary bearings spinning around the outside. So let's now come to the circle tool with a given center and radius. I'm going to go back to my 11 millimeter radius, 22 millimeter diameter. And with gridlock turned on and with line put back to a solid line style here, I'm now going to position where I want that to be. Now, I don't want it to be outside this dotted circle because then my feeling is it's going to be uncomfortable to hold and collide with the lower profile of my thumb here. So I want to make sure I'm going to put this bearing inside the circle, and it just so happens that if I snap it there, then there's actually a 2 millimeter little gap just here. I can just prove that. Let's come to the dimension line tool here. There's actually going to be a 2 millimeter gap happening. I'm going to zoom in here for more control. There you go, right there. Okay, so in that particular case, I'm thinking now that, with regard to the development of my CAD file here, if I come to the circle tool again, I'm going to go for a 13 millimeter radius, which is 2 millimeters greater than 11. And I'm going to imagine gridlock on again. I'm going to pop that there. And I'm going to imagine here that that might be, let's delete that dimension line. That might be the profile of the material which is holding the bearing in place. Now, at this point, I'd want to do a prototype. I'd want to make sure that the material there is going to be thick enough. It's going to be a friction fit for this bearing inside the laser cut acrylic 5 millimeter thick spinner. And is that going to be too fragile? Is that going to crack as I push the bearing in? So that definitely needs some testing there, but I'm going to persevere with it. Okay, so let's have a see here. I'm now going to select that that bearing and that surround point there, the thickness of the material around it, and I want to now define this as being the 3 kind of planetary bearings that are going to spin around. So to do this, I'm going to come to my rotational symmetry or rotation transformation tool. Here it is, and I'm going to rotate that. Let's see. Now I've actually got this set up here already, but let's just confirm what's happening here. Let's bring up the calculator. Okay, and with the calculator here, I know that there are 360 degrees in a circle. Whoop, let's try that again, shall we? 360 degrees in a circle, and I want to have 3 bearings. So I'm going to divide that by 3, which means that the angle I want to rotate through is going to be 120 degrees between each bearing. 120, 240, 360. Okay, let's just minimize that for a second. So I've selected this bearing and this outline for the acrylic cutout. Rotational transformation, 60-degree angle. I don't want to repeat that 2 more times. I've already got 1. I want to repeat 1, 2. Let's confirm, and then again with grid lock turned on, so everything's snapping to the grid. I'm going to click there. Whoop, hang on a second. That was complete rubbish. I got 120, and look what I put into my settings. I put into my settings 60 degrees. That was complete rubbish. 120, dearie me, 120 degrees rotation. Let's try that again. There we go. I wasn't checking my settings, was I? So those are the positions of my bearings perfectly aligned around my central bearing and the center of the spinning fidget spinner. Now, I need at this point to insert some kind of profile that's going to sweep around here, that's going to join this together. So I'm going to look at this in a variety of different ways, going from simple to more complicated. So let's do a simple design here to begin with. Now then, how might this look? I'm going to get a line tool, okay. I'm going to click on this center point here for this bearing. And what I'm wanting to do is make it so it comes across onto the center of this bearing. But I can see here that I don't know where the center of that bearing of that circle is. It certainly isn't that point there. I can see that's physically off. However, what I've got on the side here is a radial lock tool. I'm going to right click on this radial lock tool, and I'm going to define my step angle here, not as 45, which means at the moment you can see it's going from 0 to 9 to 45 to 90, 135, 180. I'm going to change this, and I'm going to put this to 15 degrees increments. So now it's going 0, 15, 30, 45, 60, 75, 90, etc. And if I come down here, I can see that's actually snapping beautifully across there. Now, I still don't know exactly where the center of that bearing is, but it's starting to give me some sort of indication. So I'm actually going to extend that too far. I'm going to extend it to there, okay? But I want to know where the center of this bearing is. So here's my next task. I'm going to now turn off radial lock. In fact, one thing I'm going to do with radial lock, I'm going to leave it turned on here, and I'm going to make it so it's only active when drawing lines. And that's really useful because now I can leave it turned on, and when I'm drawing, things will snap. But when I'm not drawing, escape that, I can basically what am I trying to say here? Yeah, I can basically just move my cursor around normally. So I'm going to click on the center here, and I'm going to do a vertical line straight up. And then I'm going to take this line and I'm going to apply the same radial transformation to it. 120 degrees, 2 repeats, based around that center. And now what I get is an intersect between this line, which is the center of this bearing, running down at this was, let's see, 15, 30 degrees. It's therefore going to pass through the center of this bearing, but I don't know where the center exactly is. And now I can see with this intersect coming in from the center, this intersect here is actually the center of that point. Now, using the delete part tool, I'm going to pull this back. I want to pull this back. And what I now get is an actual precise location where that is the center of the circle. So that means now that I can be certain that this point is running from the center of this bearing to this bearing. In fact, actually thinking about it, I didn't actually have to do that. I didn't actually do this at all. I got carried away there. The fact that I'm working with this radial lock here means I can just snap that across to there, and then I can, yes, and then what I need to do, that's why I had to do it, because I wanted to run a line across here. Now, actually, I could just run a line across like this, but to be absolutely precise, let's just trim that line back there as well. And then what I can do now is turn off the radial lock tool, turn on the attach tool, and then turn off grid lock as well, and then literally just snap that in. Now with this attach tool, if I bring my box so it's overlapping the corner of that intersect, then it's going to snap in onto the point, and hopefully you can see that in the video that's snapping in. And so what I've now got is this kind of this equilateral triangle, and if I can actually just select this shape, copy it, make sure attach tool is off, grid lock is on, paste it again, bring it off to the side, and then let's just try and clean this up a little bit and see exactly what we've got. What we have is a fidget spinner design. Well, didn't want to do that, did I? I don't know why that's not trimming back there to the circle. That's very bizarre. Okay, let's just, okay, I've messed it up there. Okay, there we go. We've basically got that as our fidget spinner design. As I say, I wanted to pull that back there, and bizarrely, it's not trimming up against these edges. So that's one fidget spinner done. Okay, let's now get rid of those lines. Don't want that. Don't want that. what else am I going to do with this? Let's just have some lines. There we are, back to where we were. Let's just have some lines coming straight across. How about that? How about I come to a line tool here? And look, in this line tool, I hold the mouse button down. I've got draw a tangent between two arcs or circles. What I can do now is click there. I can click there, and I just draw a line that basically becomes a tangent to the edge of the circle. Boom. That was super easy. Why didn't I do that first? Okay, let's take that. Let's copy that. Make sure grid lock's turned on. Pull that to the side. There's another fidget spinner design. Awesome. 2 fidget spinners. Okay, let's do another one. Let's just delete those lines back. I want to do one now that's going to be more curvy. So to do this, let's ever see what tools I've got in the circle tool option. So I've got one here which is going to draw a circle that intersects with tangent to 2 lines, arcs, or circles. This sounds incredibly, incredibly complicated. So let's see what I'm going to do here. I'm going to click on this circle. I'm going to click on this circle and then see what happens. And look, I get this thing happening here. Now, I really love the idea of what's going on here. If I draw that, if I click now, that's wrong. Let's be certain here. In fact, if I just turn grid lock off here, let's see what happens. Yeah, you can see that it's not snapping onto that second circle down here. So I'll leave grid lock on. Okay, so that's very close. In fact, it's almost perfect, isn't it? Let's just do that again. That was pretty cool. I didn't expect that to happen. Was that a fluke? Where was it? Okay. Okay, it actually clicked in. I think that was going to be the case, but there you go. Because as I was moving around there, I thought that this was going to literally appear here. But no, if I'm kind of getting the basic size of the circle there, aren't I? And then when I'm happy with it, I'm just going to drop it, and there it goes. How cool is that? Okay, so now all I need to do with this is come to the delete part tool. Hopefully this will work. Delete it back there, delete it back there. Yes, delete it back there. Now, what am I going to do with this? I want to have this looping all the way around. Now, of course, what I could do is I could come back to this tool and I could draw there, and I could try and put that to the same size and draw there and try and put that to the same size. But how do I know that they are all the same size? I mean, the reality is if I click this back like this, let's do all that. Okay. Are they all the same size? It kind of looks it, but this one definitely looks a bit smaller and that one looks larger. Now let's come to a radius tool and see what the radius of these circles is going to be. So that radius there is 37. That radius there is 23.06, and this one is 32.28. Okay, so they're all different, and that's obviously no good. So let's just undo all that. And I'm going to undo those as well. Boom, bada boom, all that too. Good, 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 good. Come on, keep going, keep going. Yes, good. What I want to do is keep this arc. So I'm going to select this arc here. And now, of course, I'm going to come back to my transformation tool. I want to make sure I'm going to rotate this again, 120 degrees, 2 repeats. I need to make sure gridlock's turned on. I'm going to choose the center and boom, there we go. That is now my fidget spinner looking awesome. Okay, now let's take this now. Let's copy that. Let's come down here. Let's paste it into here. And then now, in terms of cutting out on the laser cutter, how am I going to do this? Right, well, the way I would do this is I would come to the contour tool. I would put a 0mm contour spacing with a graphical path. I'd make this blue. And I want to cut this out in the order that I want the laser cutter to actually remove the parts. So what I don't want to do is click on the external profile first, because that would cut the external shape and then cut out the internal circles. But by cutting out the external profile first, the acrylic can basically drop or dislocate in the laser cutter, and then all the other circles are out of alignment. So I need to make sure I do all my internal cuts first and my external cut last. So I'm going to undo that, and then now with this contour tool, I'm going to click on the inside edge, inside edge, inside edge, inside edge, outside edge. Okay, over here, inside, 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 and outside to finish. Over here, we're going to have, now this is going to be a problem here because look, the inside cutout is not going to work with this triangle. Let's just do that cutout there. I think in this particular case, I'm going to have to change my plan a little bit. I am going to have to, let me think about it. Yes, 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 yes. I'm going to have to trim that line there, that line there, and that line there. I'm hoping this is correct. Then I'm going to contour. Let's just think about this. No, then I want to have that line, shift select that line, shift select that line. they want to be blue. And then finally, contour, 0mm graphical contour again, external. Okay, so let's just see how these are now going to look. I'm going to basically take this. No, I'm going to select them all individually. Select, shift select, shift select, shift select, shift select, copy, paste. Right, and that's that one. Perfect. Select, select, shift, 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 copy, paste. That's that one. And then over here, select, shift, select, shift, 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 copy, paste. There is that one. I have got there 3 awesome, perfectly balanced, perfectly aligned fidget spinners, which are designed to fit in children's hands aged from 8 years plus, give or take a little bit of accommodation. Okay, I hope that was useful. The key things I'm trying to get across here are, doing your research, particularly for standardized components like bearings and for anthropometric data of the sizes of human beings. In this particular case, the size that we can, the space that's available between the index finger and thumb grip as we look down into the base of their thumb arc here. I'm trying to describe in words there, but I'm struggling, but it's basically that bit there, isn't it? And how I've used some of these awesome tools, tangent tools and transformation tools in Techsoft Design and the grid and the attach tool and the radial lock tool to make these precisely engineered fidget spinner parts. I hope it was useful. Have fun.